So it has come to this. Blender Diplom has written its very own add-on. And while this is not that complex and it's probably even got limited uses, so I doubt it will be in the trunk, but still it is a nice little add-on that we'd like to share with you. And I'd like to show you how we coded this. Now, what the add-on does is take in an animation and replicates it, puts it onto another object with an offset in time and space. So that probably sounded pretty complicated, so I'm just going to demonstrate. What I did is I took this plane here and I put 3 keyframes on it, or 4. I have a Euler rotation around the y-axis, which makes it flip over like a domino. And then the restrict render here. The restrict render is actually the little camera icon that you have up here in the outliner. Right here, if you hold I over that camera, you can make a keyframe, and if you then click on the camera on another frame and press I again, then you have a render restriction. And you can see as I scrub through the timeline, those start to get rendered, and it's always as soon as the last one lands, the next one will get rendered. So those are actually constant keyframes. They are true or false, and these are procedure keyframes, or well, they have an interpolation. So this flips, and then the next thing gets rendered. Flips, gets rendered, and so on. And if we click through them, we can see it's always the same animation, except for it's offset by 10 frames. Okay, great. So if we render this, we'll get a series of flipping images that will then form a line or something. I have even extended the script, so you can just put images in a directory and name them image 1, 2, 3, and so on. So they get mapped onto these objects without having to do anything further. But that's a lesson for another time. So a Revo will do in this lesson is simply take an animation, offset it by a location and time. So you can, for example, do this card flip thing or do these lollipops. So all Gottfried did here was animate one, use the Revo, and then animate the rest of them. Okay, great. So let's have a look at that script and try to replicate. And for coding, I like this window here. You have your viewport to see what it's doing. You have your test down here. And you have some properties and the outliner over here. So scripting, it's very well subdivided, and you can see the script is not very long. So that is very good for a little, but I think fairly powerful beginner script. Good, so let's start fresh. Press the plus key here and call this Revo tutorial. So what we need is the BPY. So we're going to import the BPY. And also we need to import some basic math features. So I'll just type in import math. BPY is the Blender physics without which not much will work in the Blender Python coding. Now we have to ask ourselves, how many variables do we want to define? And for example, here I have a couple of images, I don't know, 23 minus the camera, so it's and the ground plane, so it's probably 21 images. And I need to define how often my Revo will compute the new object. So I'll just call this variable loops. This defines how many loops we will undergo, and I'll just set this to 10. You can change that later on. Then we need to define a distance, how far the next replicated object will be away from our original object. So I'll just call this distant x, and I'll just put 0.1 here, and distance y and distance z. And You could of course make an array from this. So you just call it this array distance and call the 0, call it array index 0, that would be the x, and the distance index 1 will be the y. But just so it's very clear that this is actually the distance in x direction and so on, we're not going to use an array, we're just going to use 3 variables. It's not going to make it much more text, but it's going to make it a lot easier to see what we're doing, and especially to see what for the next guy to see what we were doing. I'm going to do the same thing. Here I'll make a rotation x, and so far we don't need that, but this is something that is a good idea to have. So while you're developing your script, it is a good idea to put all the parameters that you need to alter later on, depending on the type of animation you want to do, to make sort of a list with variables up on the top. So our list now contains the distance offset, the rotation offset, and how many objects we want to produce, or even more specific, how many loops we want this script to undergo. Then we need an offset, and this will be the offset in frames. And right now I'll make that 3. So these are the main variables that we have configured. Now we need the script to actually do something with them. The script works in such a way that I just select an object, and this selected object will then be duplicated and the keyframes will be pushed forward in time. So right now let me just delete all these so we can see a lot better what we're doing. And since we're programming an animated script, let's change this to a timeline so we have a little more handle here. Okay, now we can see, and maybe even not look through the camera. Okay, great. So now it's falling over. I have already completed this animation. It's not very hard. Just press I to make a keyframe here, rotate it by 90 degrees around the y-axis, and on a later frame press I again for rotation. Good. So if I want to actually duplicate this object, there are a couple of ways, and probably the most sophisticated way, or what programmers will probably call best practice, would be to get the name of the object, make a new instance, and then add this instance as a child to the scene. But first of all, that is too much code for my preference, and also it'll be a lot harder once we have several objects selected, because then we'd have to sort the selection and we'd have to name them so the script will recognize them. So I just found it to be a lot easier to just use the BPY operations that you can find over here in order to duplicate the objects, and this will be a lot more important later on when we use armatures with our objects. So what I do now is I'll press Shift D, and once I do this and release the right mouse key so Blender knew what I was planning, I'll see a huge list of stuff that happened. And you can see bpy.ops, so bpy blender physics.operations.object, which is this object, .duplicate move. So this duplicated the object, and then we have a lot of parameters, and that depends on how much you moved your mouse during the duplication, like so, and where you released it, and whether you pressed Alt D or Shift D, making it an instance or a duplicate. And what we need here is mainly this line. So we'll just go bpy.ops.object, just as it states up here, .duplicate move. And since we want each of these planes to have its own material, we can't use instances. So what we need to tell Blender is the object OT linked equals false. So I'll just copy that. And these curly brackets here, they show that inside these brackets here, or parentheses, a new subcategory of parameters, forgive me if this is not the correct term, I'm not a programmer. Well, what we need to do is state a few parameters. For example, linked equals false. And actually, since this is a parameter and not a variable, we need a colon. So linked equals false. And you can see that there is a lot more stuff in here, but each of these values here has a default value. And if you don't specify any of that, Blender will use the default values, and that's fine with what we're doing. So all we need to do here is to actually use the duplicate move method and duplicate it not linked. So that should be it. But in Python, false is spelled with a capital F. Good. Now, if I duplicate this, you can see the duplicate becomes the new active object. And Blender can distinguish between the active object, a couple of selected objects, which would be these dark orangey ones, or unselected objects. And of course, once we've duplicated this, the active object is the one we need to do stuff with. We need to transform. So I'll call a new variable object, or obj, equals bpy dot context dot active object. So that means now my obj is the newly created copy, and now I can do stuff with it. And if you want to test parts of your script, you can use this console. And you can also use it to check whether a command is available or not. Now I just pressed Ctrl C and now paste this by pressing Ctrl V, and then I'll press Enter. Nothing happened, but actually the obj variable is now the active object. So if I trace it, just by typing obj, that will trace it. It will tell me bpy data objects and then the object name. This is actually a one-dimensional array with only one object name in it. Now I can do stuff. For example, I can set its obj dot location. Let's take the z, which is 2, and we'll add 2. It will jump up by 2 Blender units. So plus equals means we're adding 2 to the current value. And if we don't use the plus, we can just 0, then it'll jump back to the middle. So this is quite cool. So we can already test parts of a script just by typing them in here. That would be the same thing as if I write a script with only 1 or 2 lines. If you're counting this line, then it's got 2. And pressing the run script, except for I don't need to run a lot of scripts and don't need to undo a lot of things. I just can type in single lines over here, which I enjoy very much. Now we know that the new object, the one we just duplicated, I can actually write that here, the newly duplicated object. We want to do stuff with it. For example, I want to offset it by exactly 1 width of this. And, or actually a little bit more than the width. So let's just see, the x is 1.083. So 0.1 is a bit too little. So I'll just take 0.11. And now I'll take the object dot location 0 and make it correspond with the distance x. This is what this will now offset the original location, which is right here, by 2 or by 1.1. There we go. this is what this line does. It will jump 1.1 units in x direction. Great. And since we want the script to be able to offset in any direction, we'll just copy this line twice, and then this should be a 1, this should be a 2, and this should be a y, and this should be a z. And ta-da, our script is ready to work in all 3 dimensions. Now, same goes for the rotation, so it's basically the same thing. I'll just choose the object location and make it a rotation, and here also rotation, and duplicate this 3 times, y, z, 1 and 2. So as long as you leave these at 0, these lines won't do anything, because adding 0 obviously does nothing. So we don't need to change our script if we want to use an y offset all of a sudden, but we just need to fill out these new variables, which is why I recommend storing the important parameters here and not using absolute values in here and then go in and change your entire script every time you need to change a value. Okay, that was the easy part. Let's put that in a for loop and see what happens. For example, I want a for loop for I in range loops. And this is a common thing in a programming language. For loops are very straightforward. It does as much as I is in range of loops. I is starting at 0, and it will be increased in every frame until it reaches loops, so 11 times, if I'm not mistaken. So it starts at 0, and then for 10 times it will be increased 1, so at the end it's 10, but it's 11 loops because the 0th loop will be counted. Now you can see there is a colon here, meaning this whatever follows next is what you're supposed to do, but that needs to be indent. So I'm just going to mark all of this and press tab. And now Python knows that all that is indent here is part of that for loop and will be executed loop times. Try to run our script, and you can see there's a fail message, so we'll just go to our Python and we can check in line 21 there is something wrong. Object has no attribute rotation. So apparently rotation is called something else. Let's just find out what. We can just copy this line again because I restarted Blender, so it does not know that obj is actually supposed to be the active object. So I'll do that again. And now we can check the parameters. We can now type obj dot and then press Ctrl space. And you can see a huge list of things pops up, and one of them should be our rotation. For example, we should look under the letter R, and we can see rotation axis angle, rotation Euler, rotation quaternion. And the reason why it doesn't find it is we have to specify a rotation type, and we want Euler. So the other ones I don't like. Sorry about that, but yeah, I prefer the Euler or Euler. Euler is the correct pronunciation, and that is why we're going to use that one. So let's delete these two and just change the rotation to underscore Euler. So let's try this again, and you can see it works like a charm. But they are far too closely spaced, but that's because I made a decimal error here. Let's just change this to 1.1 and we should be fine. And if we have a look, of course, now they are all doing the same thing at the same time. And now there's something you need to be very careful about. You can see I just change this value, and if I now press undo here until I have undone what the script did, so there are no more copies here, which is a lot easier than deleting all the copies, you can see that the values of my scripts have changed again. And that is something you need to be aware of, because that cost me a couple of hours already, just figuring out why I put some new values in there and nothing changes. It is because I put them in there before I pressed Ctrl Z, and that caused Blender to actually undo my fixes. Okay, great. So this is the for loop for you. All this does was duplicate the object here and then offset its location and rotation by the values we specify here, and it will do it this many times. So let's do the more important part. We need to offset the animation, because this is something that anybody can just do. You press Shift D, offset it, and then you select everything, press Shift D, then you have 2 to the power of how many times you do that copies. That doesn't take very long to fill the screen. So the magic is actually that we can offset the animation of each object by a given frames. And these are the frames at the moment, 3 frames. Good. For that, we need to get the animation data. So I'll call a new variable, and this is anim data. This name is not important, just as the obj is not important, but you need to give it a meaningful name so you'll find it later on. And this is simply the objects.animation data. Now we need another variable for the f-curves, and these are the f-curves of the animation data of our object, and our object animation data is already stored in this one, so we can use this variable, use it, and call the f-curves of this object. Okay, the name f-curves here is arbitrary. You can give it any name, but I think it's a good idea to just call this whatever the parameter here is. And you can see this looks like a duplicate name, but it's not, because this is sort of, in layman's terms, in a subdirectory of the animation data. But I just realized you can't call the f-curves of the animation data directly. You need another variable, and I'll call this action. And this equals the animation data dot action. Action is this here. You can see here. So the animation data is all that's here. The actions of the animation data is, for example, this one. And then we need the action.fcurves, which are the f-curves using those handles, for example. So now we have all the parameters we need, all the variables we need to change everything. I'm going to make another for loop, and this for loop needs to have as many loops as there are curves in f-curve, as many times as there are curves in f-curves, and colon. Now we need to store our data, and we need to check how many keyframe points we have in each curve. So the keyframe points will be these handles. This is a keyframe point, this is a keyframe point, and so on. So let's imagine we're in loop number 1, then we'll just say this is the first curve in f-curves, so curve dot keyframe points. Now if you have a Bezier keyframe, which is preferable because we want a nice smooth animation and not constant or linear, then your keyframe points will have handles. So what we need to do is, for each keyframe point, we need to have a for loop consisting out of 3 this time to change every handle. Now I can press G here, of course, and move this around and check what happened up here. Problem is, if I press Shift D here, it does something very different from pressing Shift D with my mouse over the F-curve editor. And you can't tell your script where your mouse is at the moment. If you use the BPY ops transforms, Blender will always assume that your mouse is over the viewport. So manipulating anything in the materials or the graph editor does only work with the script if you're using the direct commands and not the global ones, the operations here. So we know that we have to handle the handles of each keyframe point. So for this time I'll call it keyframe. In keyframe points colon, I need the keyframe center, and that is called CO, and 0 is the X position, so time. 1 would be the magnitude. With X position I mean, of course, X is time and Y is magnitude, so 0 would be the coordinate 0, and I want to add to that our offset. So now the keyframe center will be offset in time by 3 frames, which is specified up here. Now we don't only need to offset the coordination center, we also need to offset the handles. So keyframe dot handle left, also offset it by offset, and I made a little mistake here. This of course needs to be a dot because this is all from the same keyframe, so these are sort of the sub directories or the sub variables that are stored in the keyframe depth. And of course we need to do this for the right keyframe handle as well. Control V and just exchange this to right, and that's it for the offset. Okay, now let's try and run this script again. We got another error message and line 32, which is here, and that is because we tried to add a single number to an entire array, which does not work. We need to specify a position in the array, which I did here correctly, but I left it out here and here, so this is why the script failed. Let's not undo this, but let's delete this copy. So this is exactly what I wanted to show you today. We now have a lot of little objects doing what the other object was supposed to. Right now, this script is very simple. There is no location keyframe in this animation. If I were to set a location keyframe on my first object, we'd run into a great problem actually. We didn't run into it because there are no location keyframes here, but let's just put one. Just I location and run the script again. You can see they're all offset and it looks fine, but watch what happens if I press the arrow forward to go to frame number 0. They all jump to the same location because they have been moved by the script, but they still have a keyframe. So this would be the same thing as if I moved it here and then press the arrow key, it will jump back to where its location keyframe is. So we have to compensate for that. And for that, let's use a new object. I'll hide this one, Shift C, add mesh monkey, and then I'll use this other command here that my OBJ should be the selected object, which it is. And now I'll make a keyframe location, move the monkey over here, press arrow, it will jump back. Now I'll say obj dot delta location plus equals 3, 2. And of course, same mistake, we need this one. you can see the monkey moved 2 in this direction, and if I move the cursor, it will stay there. Delta is Greek D, and it stands for difference. That means to whatever the monkey already has, I will just add 2 and call this not the location but the delta location, which is perfect because if my monkey now has location keyframes and I duplicate it, if I move the absolute position of the monkey will jump back to its original keyframe. But if I don't use the original location but rather the delta location, my monkey will do the same thing but offset or with a difference of whatever difference or distance we specify here. So just by changing the object's location to delta location, we can make this animation independent of location keyframes. And in Gottfried's lollipop example, we'd also have to use delta rotation. And you can just see this is a very simple fix to a fairly complex problem, because if we were not to use the delta, we'd have to rewrite the script if we want to use a location offset or a rotation offset. So this is a very simple trick that probably animators thought of a long time ago and that we can now make use of. So that's it for chapter 1. You can see it's a very, very simple script, fairly powerful, especially if you render very extensive and a lot of objects. You can achieve some pretty cool effects. And how to extend this, including armatures and maybe some more, if I can think of any effects, is what you will see in the next chapter. Thank you for watching.